Good morning, students. Today I am explaining problems on DC motor. That is a torque equation problems. The last video lecture I will explain problems on DC motor only. Now I am explaining torque problems on the torque. The first problem: a 500 volt shunt motor has a four-pole wave connected winding with a 492 conductor. It is a Z is equal to 492 conductor. The flux per pole is 0.05 bar. The full load current is 20 amps. The armature and shunt field resistance, armature resistance 0.1, shunt field 250 ohm respectively. Calculate speed and develop the torque. Just see the figure. The parallel connection, that is RSH, a field connection parallel because of shunt field is nothing but parallel. RSH is 250, ISH, IL, IA, RA is 0.1. This is 500 volts. P equal to 500 volts, P equal to 4, Z equal to 492 conductor, flux is 0.05 bar. That is line current is 20 amps. First you calculate ISH. That is V by RSH. V is 500, RSH is 250, 2 amps. IA equal to IL minus ISH. That is 20 minus 2 to 18 amps. That is EB is the back EMF of the motor. VA minus IA RA. VA is 500, IA is 18, RA is 0.1. Simplify, that is 492.2 volts. Final answer is 492.2 volts. That is EB. EB equal to formula 5 PNZ by 60 into A, where A equal to 2 for the wave type. Directly you calculate a speed. That is 60 into A equal to 2. EB is 498.2. Just now calculate EB. Just you put the EB value 498.2 divided by 0.05, 4 pole, 492 conductor equal to speed is 607.56 RPM. Next, once you calculate again, easily calculate TA, the torque developed in the armature. That is formula is 0.159 flux IA ZP by A. Just putting all the value, flux 0.59, flux value 0.05. I is 18, 492 conductor, P equal to 4 divided by 2, A equal to, you get T equal to 142.8104 Newton meter, 142.8104 Newton meter. Okay, next problem number 2. The 4-pole DC motor takes 50 amps armature current. The armature has a lap connected 480 conductors. The flux per pole is 20 milliweber. Calculate gross torque developed in the armature of the motor. That is again TA you calculated. Okay, the P equal to 4, A equal to P equal to 4, Z equal to 480 conductor, flux is 20 milliwebers, 20 into 10 raised to minus 3 weber, I is 50 amps. Directly find out TA, just substituting all the values, 0.159, 20 milliweber, 50, 4 into 480 by 4 because of A equal to P. That is lap. You get TA equal to 79.394 Newton meter. Okay, next problem number 3. The 4-pole 220 volt slab connected DC shunt motor has 36 slots. Each slots contain 60 conductors. That is 36 into 16. Because of each slot's conductor is 16, you get Z, total Z. The current of 40 amps from the supply. The field resistance and armature resistance are 110 field resistance, armature 0.1 respectively. The motor develops a current output power of 6 kilowatt. The flux per pole is 40 milliweber. Calculate speed, torque developed by the armature, shunt torque. Here the two torque. First you calculate torque of armature TA, next shunt torque. Just write on the given data. This is also example problem. 2004 January, 2004 August. This is 7 marks. Very important problem. That is P equal to 4, V equal to 220 volts, slab connected A equal to B equal to 4, 36 slots, each slot 16 conductors. That is ISH equal to V by RSH, that is 220 by 110, that is 2 amps. Just see the figure ISH, RSH, RA, 220 volts, IA equal to IL minus IH, 40 minus 2, that is 38 amps. P out, the power output is 6 kilowatt, flux is 40 milliweber, given data. EB equal to V minus IRA, V equal to 220, IA is 38, RA is 0.1, we get 216.2 volts. Next, EB equal to 5 PNZ by 60 into A, that is Z equal to 36 into 6, 536 into 6 because of each slot 16 conductors, 36 into 6 is 576 conductors total. Just putting EB value 216.2, flux is 40 milliwebers, P equal to 4, and as it is, you calculate N. Z is 576, 60 into 4. We get N is 563.02 ampere. Okay, next TA equal to torque developed in the armature 0.59 flux IA PZ by N. So you get just substitute the values, you get T 139.2 no 207 Newton meter armature torque. Next to shaft torque, third one, P out by W. What is P out? Already given in the problem. Power output 6 kilowatt. Omega is 2 by 60. You get TSH, that is 101.7325 Newton meter. Okay, next problem. Problem number 4. The field current in DC shunt machines is 2 amps and line current is 20 amps at 200 volts. Calculate generated EMF when working as generator. Torque in Newton meter when running as 1500 RPM as a motor. Take RA is 0.5 ohm. First, as a generator, you see the figure. That is generator RSH 2 amps, 22 amps, 20. That is 22 minus 2 is 20. As a generator, VT terminal voltage is 200 volts. The line current is 20 amps. Directly find out generated voltage. Easy. That is VT plus. Why plus? Because generator. You generate the voltage. VT plus IRA. 222 into 0.5. We get 211 volts. That is 211 volts. That is generator. As a motor, torque when the running as a motor. This EB equal to VA minus IRA. 200 minus 18 into 0.5. That is 191 volts. That is EB. In power output, mechanical power developed, that is EBI. 191 EB, I is 18. We get 3438 watts. Next, TA equal to mechanical power divided by omega. Mechanical power is 3438 watts. Omega is 2 by 60. Just we get T, that is 21.887 Newton meter. 21.887 Newton meter. Stop the video.